Product rule. Now, the textbook says this as a watch out term. Make sure you can spot the difference between a product of two functions, which is what we're using now, what I'm teaching now, and a function of a function. A function of a function, you use chain rule, as I've taught you. So function of function is f of g of x. Here you use chain rule, remember, don't forget. So don't confuse this with product rule, which I'm about to teach now. Product rule is when you have two functions multiplying. We have f of x times g of x. This is not the same as this. Remember, this is a composite function. This is two functions multiplying. So in such a case, you use product rule. In such a case, you use chain rule. Don't confuse. With time, you'll easily notice the difference between them. But for now, just be cautious. So a good way I like to think of it is, in composite functions, you'll almost never have, you may see this, this is not a foolproof method, but just an easier method for the beginning, for beginners. Try to look for the number of x letters you see in the equation. If it's two or more equations, but then they're separated by pluses, then it's a composite function. Let's say x squared plus 2x plus 5 all raised to 2. In this case, we see this letter x and this letter x, but they're separated by plus. So they're not multiplying. So this is a chain rule application. But when you have a product rule, so when two functions are multiplying, you'll clearly see a function in terms of x is multiplying with another function in terms of x. So for this, there's a general rule. If y is equals to u v, where u and v are both functions of x, then dy dx is just u prime v plus v prime u. So basically, differentiate one times the other one as it is, and then differentiate the other times the other one as it is. So what does this mean? Right now it's kind of confusing. Let's see. An example. F of x is x squared into square root of 3x minus 1. Now, here you see clearly that it's not a function inside another function. It's a function in terms of x multiplying with another function in terms of x. Chain rule would be different. I've shown you the cases where chain rule is commonly tested. So in this case, x squared times 3x minus 1 all raised to a half. How would you differentiate this? Again, so you say u is x squared. You just give each of this a letter. So u is x squared and v is this other one, 3x minus 1 all raised to a half. So now u prime is the derivative of this is just 2x. And v prime, now here we have to use chain rule. This inside this product rule, this function, to differentiate this, we have to use chain rule. So chain rule is very important. You'll see it everywhere. So to differentiate this by chain rule, remember half into the whole inside function, 3x minus 1, all raised to negative half times the derivative of the inside function is 3. So we get 3 over 2, 3x minus 1, negative a half. So we have uv and u prime v prime. So the final answer, which is the derivative of f of x, we in set notation we write it as f prime of x is uv prime. So it will be this multiplied by this. So 3 over 2x squared into this 3x minus, okay, I'd like to write 3x minus 1 raised to negative a half. You can use the rules of indices to manipulate this, put it down here so it becomes 2 root of this, I don't know, and then uv prime and then vu prime plus 2x into this thing again. So 3x minus 1 all raised to a half. So that's all. You first separate the functions by clearly looking. This is a separate one from this. Write them down as u and v. Differentiate u to get u prime. Differentiate v to get v prime. In that general formula, uv prime plus vu prime. uv prime plus vu prime. And that's all for product rule. in my opinion, product rule is easier than chain rule, because chain rule you really have to see the outside function and the inside function. Remember, that one is a function of a function. It's not functions multiplying. So let's say again, now another example in the textbook. Y is e raised to 4x sine squared of 3x. So now this is where it gets complicated, but it's really not. It's just a basic application of the rules we've already done. Again, here you see this function of x clearly being multiplied by this function of x. It's not function over function. It's not function inside a function. These are multiplying. So you say u is e raised to 4x and u prime. This one is an application of chain rule. Outside function remains, and then inside function is 4. The derivative of the inside function is just 4. So 4e 4x. You can pause the video to figure out how we got this. Is just chain rule, because the exponential retains from the basic rules times the derivative of the inside function is 4. Yeah. And then v is this function, sine squared of 3x. So I'll write it as sine 3x all squared. V prime, again, to differentiate. Usually in questions of product rule, each u and each v, to differentiate those, you have to use chain rule. But now that we know it, it's relatively easy, isn't it? So to differentiate this, the outside function is raising a bracket to power 2. So that becomes 2. The inside function remains the same for the first part, 2, and then power 1, because 2 minus 1, times the derivative of the inside function is now again, actually this is a case where there's 3 composite functions. And the derivative of the inside function is cosine 3x times 3, because yes, you get it. So although I said it can be only two functions compositing, it can be 3, but this is very simple, isn't it? You do the outside most first, that's this, and then the inside most is sine of 3x. To differentiate just this, it's also a chain rule, because sine of 3x. But then it's relatively simple. It's not that hard, is it? So 3 from the inside part times cosine 3x. So finally this simplifies out to 6 cos 3x power 1 just means sine 3x. So the overall derivative is uv prime plus vu prime. Uv prime, this times this, so 6e4x into this, cos 3x sine 3x plus this into this, so 4e4x into sine squared 3x. And that is indeed okay, you can factorize out e raised to 4x sine of 3x in both cases, and that'll give you the form the textbook wants. But for now, let's not worry about all of that. So that's it for product rule. For product rules, it's 2 functions multiplying each other, but each of those functions can have a chain rule when you want to differentiate that one in specific. So that's it for chain rule. Again, okay, now we go to quotient rule. Quotient rule. This is actually the easiest in my opinion. It's because it's easy to spot. You know, when you're doing calculus, it's not really hard to do the stuff when you know what to do, but it's the spotting that's hard. You have to be good at spotting when to use chain rule and when to use product rule. Either using the wrong one will give you a wrong answer. So for quotient rule, it's very easy. It's when you have a function dividing another, u over v. U is a function in terms of x, v is another function in terms of x. This one is so easy to see because you'll see a function of x over a big ass line and then another function down here. So this is very easy to spot. Now, in this case, the formula, okay, you'll get used to, you won't even have to cram the formula, you'll get it very used up, but you'll get used to it. It'll become part of your muscle memory as you do more questions. But in this case, if it's u over v, where u and v are both functions of x, the derivative is vu prime minus u prime, sorry. The general formula is vu prime minus uv prime all over v squared. So the only hard part of quotient rule, which is not really hard in the beginning, it might seem hard, is just knowing this, but it's not that hard. vu prime minus uv prime. Remember, the order matters because now we have a minus sign. A plus sign order doesn't matter, but when you have a minus sign, the order matters. It has to be vu prime minus uv prime all over v squared. So that's just a general formula. Let me write it in the corner for when we do examples. vu prime minus uv prime all over v squared is how you get the derivative. So an example, very simple one. Y is x over 2x plus 5. So u is x and v is 2x plus 5. U prime is 1, v prime is 2x plus 5 becomes 2. So again, this is a very simple case. vu prime is vu prime. So 1 into this, which is just 2x plus 5, minus uv prime. So minus 2x all over v squared, which is 2x plus 5 all squared. 2x subtracts, so it's 5 over 2x plus 5 squared. This is the derivative, dy dx. That's all. That's all for quotient rule, except it gets more complicated, obviously. Let's have a look at some more examples. Let's say y is sine x over e to 2x. Okay, so in this case, again, the rules stay the same. U is sine x, u prime is just cosine x from basic definitions, and then v is e to x, v prime is 2e to x. Again, this is from basic definition. So the derivative is uv prime 2e to x sine x minus v. Oh, okay, my bad. Even I messed up the order. My bad. It's vu prime. So e to x cosine x vu prime minus uv prime 2e to x sine of x all over v squared, which is e to 2x squared will just become e 4x from indices rules. And yeah, that's all. And then this is the derivative. Remember, all the other basic rules of derivatives apply. You plug in a value of x, you get the gradient at that point. And you want to find turning points, you equate the whole derivative to 0, because at turning points, gradient is 0. And yeah, that's it for quotient rule. And then a very specific application of quotient rule, you might notice for trigonometric functions we did sine and cosine. What about tan? So again, very simple. We'll just use basic definitions. Tan x is sine x over cosine x. Now the heading is very convenient because quotient rule is what we use to differentiate this. It's a function of x dividing by another one. So to differentiate this, let's u is sine x, u prime will be cosine x, v, the down one, is cosine x, v prime will be negative sine of x. This is from basic definitions, remember. So dy dx will be vu prime cos x, which is just cos squared x, minus this times this. So this is sine x times negative sine x all over v squared is cos squared x. So sine x is negative sine squared, but then this negative makes that positive, so it becomes cos squared plus sine squared, because this is negative sine squared, and then that already negative that exists in the formula will make it positive. So cos squared x plus sine squared x. And then remember, sine squared plus cos squared is always 1. So this is 1 over cos squared x, which is sec squared. From what you've learned in P3 already, 1 over cos squared is sec squared. So to summarize it, if y is tan x, dy dx is sec squared x. Very nice. So then the textbook continues. Now we can use chain rule again. So if, let's say, you have, this is now a general result, you can remember this and it'll make your life easier. So let's say y is tan of 2x. So to differentiate this is an application of chain rule. you differentiate the outside function first, which is tan, so it becomes sec squared of the inside function remains the same, sec squared of 2x times the derivative of the inside is 2, so 2 sec squared 2x. So the textbook says this as a general rule, tan of kx, where k is a constant, becomes k sec squared kx, which makes sense, doesn't it? Because it's the same thing I just used in the example. Now the textbook is going in very okay, another example. Let me just do it very fast. Y is cosec x, so this is just 1 over sine x, isn't it? Yes. So to differentiate this, you can say u is 1, so u prime is 0. When you differentiate 1, you get 0 because it's a constant, remember. And then v is sine of x, so v prime is cosine x, so the derivative is v u prime, 0 sine x is just sine x, minus u v prime, so minus 1 cos x, so minus cos x, all over sine squared x, because v squared. And this is the same as negative 1 over sine x times cosine x over sine x. We opened up this sine squared to give sine x, and then we took 1 of the sine x for 1, which is allowed, and then that, which gives negative cosec x into cot x, because cosine over sine. So that's all for these hard trigonometric functions. The standard results for all this are given in the formula booklet, so you really don't need to worry about that too much. And then a final example for arc functions, because you need to know that. Say we have y is arc sine x, arc sine of x. So to differentiate this, firstly you interpret that if y is arc sine x, then x is just sine of y. Remember, arc sine is just sine inverse. So if we have, let's say y is sine inverse of x, to get x, you just do sine of y, don't you? So that's just this. Now, this is where we'll be using that special rule. So dx dy is cosine y, isn't it? Yeah. So again, when I said before, dy dx is 1 over dx dy, didn't I? So in that case, then dy dx would be 1 over dx dy. So dy dx is 1 over cosine y, because cosine y is dx dy. But then remember, sine squared plus cos squared is 1. So cos squared y is 1 minus sine squared y. So cosine y is just a root of 1 minus sine squared of y. And then sine y is just x. So cosine y is root of 1 minus x squared. So the derivative simplifies to 1 over root 1 minus x squared. Even in this form, it's perfectly good, but then it's in terms of y. The derivative is in terms of y. We want it to be in terms of x. So we use this manipulation to get that cos y must be 1 minus sine squared, but then sine y is just x. So sine squared y is just x squared. So we just wanted to write it in terms of x. So we wrote it like that. So that and some more practice questions you should do on your own is the end of P3 differentiation. The whole of P3 differentiation has been covered just like that. Important things were the basic definitions of sine, cos, ex, ln of x, and then chain rule, very important. Chain rule will be part of quotient rule and product rule questions. When you have to differentiate the v and u terms, it can be part there. Remember, usually it will just be 2 functions, one function inside of another, but very simple cases of 3 can be there, like we saw in that question where it was let me not forget. Yeah, I remember, sine of 2x all to the power of 2, let's say. So this is the outsidemost function, raising it to 2, then sine, and then 2x. So very rare cases of 3 can be there, but then this is very simple, isn't it? So yeah, but chain rule is for function inside a function, and then product rule, function times a function, u v prime plus v u prime, and then quotient rule, function over another, which is very easy to spot. You use this general rule. So that is all. You may look at the textbook for some more examples and questions, but in summary, that should be everything, all the basics you need for P3 differentiation. Thank you. Next, we will go to integration, which will now be very easy now that we have learned the basic rules of differentiation. Thank you.